This tutorial will guide us through simple linear regression and correlation analysis for use in Stat 105 in JUMP. So the first thing to notice is that I have a data set pulled up here, and it's going to be a data set on vehicles in 2004, and gives the company name, model, horsepower, city miles per gallon, highway miles per gallon, and weight of those vehicles. And what our goal is to use highway miles per gallon as our response and weight to predict the highway miles per gallon. Okay, so in order to fit a simple linear regression model, we go up here to Analyze, then go to Fit Y by X. Now we need to slot in our response in our X or explanatory variable, which JUMP calls a factor. I already told you that we're going to use the weight of the vehicle as our explanatory variable and the highway miles per gallon as our response. It's important to note here that both of the variables selected have this blue triangle next to them, which means that they're quantitative variables, because regression should only be run for us right now with quantitative variables. So if we click OK, we get a scatter plot of our data. So we have highway miles per gallon on our y-axis and weight on the x-axis. Now, if you want to blow up the points on the scatter plot, you can right-click on the scatter plot and go to marker size, and usually I put them on medium so that they're a little easier to see. And if you want to resize the scatter plot, you can just drag, click and drag like I did there. So this gives us a scatter plot, and we can see that there's a negative linear relationship of probably moderate strength here. So in order to obtain the least squares regression equation, we go to the the red option triangle tab and click on Fit Line. Now this will give us a bunch of output here. Under linear fit, you'll see that we actually have the equation of the least squares prediction or regression model. So it gives you, it calls y hat highway miles per gallon. It gives us the intercept of 50.911 and our slope estimate, which is negative 0.0065 times weight. So, and where we would put in x for weight if we were writing the equation. It also gives us a summary of the fit. It says how many observations there are in this data set, and you can see that it gives us the r-square value. So it just kind of comes out and says it's r-square, so that's 0.51737. You see that it also gives this lack of fit section, which I just expanded, and we're not going to deal with that, so that's why I have it collapsed like I did. We're also not going to deal with the analysis of variance right now, so I'm going to minimize that as well. Down here under parameter estimates, it again gives you the intercept and weight for our slope, so it calls slope weight here. And right here are the estimates of those regression coefficients. Well, we're not done there. As we discussed in class, we also need to look at residual plots to assess the appropriateness of our linear model. So in order to do that, we can click on the red tab next to linear fit and come down here to plot residuals. We just select that and we get a couple plots here. So let me increase the size of this plot. The first plot you see is the residuals against the predicted values. So these are the predicted y values or y hat values. And well, it looks like there might be a little bit of a megaphone here going on. So that's the generic plot. It also gives you a plot of the actual y values. So on your y here, actual y values against your predicted, just to see how good of a job you're doing. It plots the residuals by basically the index. So again, you'd want to see random scatter there, just like you would up here on the usual residual plot. And at the bottom, it gives us a normal quantile plot, And you can think of that just as a normal probability plot. It shows the same thing of our residuals. Let me blow up the points here again. And again, it just shows that reference line. Unlike before, it doesn't have the confidence bands around that, but I will show you how to get that. So those are the basic plots that jump 9 spits out. If for some reason you have jump 8, there are some different defaults. They're still up here in this option tab, a plot residuals. You'll just get 1 plot rather than 4. Okay. If for some reason you are using jump 8 or an older version and you don't get all the residual plots you want, well, what we can do is we click on this option tab and go to Save Residuals. Now if we go back to our data table, you'll see that we have all our residuals here in the far right column saved. So what we can do is now go to Analyze, Fit Y by X, and then just plot or get scatter plots of what we want. So if we wanted our residuals against our explanatory variable, which was weight, we can just slot weight in there for X, click OK, and now we have a residual plot for that. Okay. Now I want to show you one other thing. If we go back to the output here, you'll see that we don't have the correlation. Now one way to get the correlation is to take the square root of r squared and figure out what sign you need based on the slope. But there's another way to explicitly calculate correlation in JUMP, and that's what I want to show you next. To get correlation, we can go to Analyze, go to Modeling, Multivariate, Methods, go to Multivariate, and then click on all of the variables we want. So let's say we just weight and highway for now, and put those in your Y columns. If we click OK, we get the correlation between the two on the off diagonal of this matrix. So you can see it's negative 0.7193. It also gives you scatter plots. So that's all I'm going to show you for now. I'll post more videos for multiple regression and model comparison later.